This video will focus on the learning targets having to do with ionic part of naming. Specifically, we're going to focus on taking a name for ionic and writing the formulas. We're going to be focused on 3 examples as we go through: writing a formula for calcium sulfide, writing a formula for iron 3 oxide, and writing a formula for magnesium chlorate. So, when it comes to taking a name and creating the formula for it, step 1, what I would do is write down the symbol for the name and then write down the charge. Focusing first on the cation, since that comes first in the name. And so the question is, given that cation, is it a main group cation, in which case you know the common ion charge, or is it a transition metal cation, in which case the charge will be given to you with the Roman numeral? So with our 3 examples, our first one being that iron 3 oxide. So since it's a transition metal, we have a Roman numeral to tell us that iron's charge is a 3. So the cation is iron plus 3. When it's calcium instead, that's one of our main group elements. When I look, calcium's in column 2, which means calcium always has a plus 2 charge because column 2 always has a plus 2 charge. Magnesium, similar to calcium, is in column 2, so it will always have a plus 2 charge. So step 1, write down the symbol and the charge. Next is to move on to the anion then, and the same goal. We're going to write the formula as well as the charge. Okay, so what you have to look at for the anion is the ending, because depending on the ending, it'll tell you where to find the formula for the anion. If it ends in IDE, that means it's usually from the periodic table. Okay, but if it ends in 8 or 8, then it's probably a polyatomic ion, and you're going to have to look at the back of the periodic table to find the formula and the charge. So for sulfide, that is simply sulfur from the periodic table. It's in column 16. 16 wants to gain 2 electrons to be 18, so it's a 2- charge. Okay. Oxide is in the same column as sulfur, that column 16, so it also wants a 2- charge. But chlorate is not chloride. It's not from the front of the periodic table. It's on the back. If you flip your periodic table over to where we have our polyatomic ions, we have chlorate right here, which has a ClO3 -1 charge. So step 2, write down the formula and the charge for the anion. Now this is the hardest part of the writing formulas for ionic component, which is now that I have the ions and the charges, I need to figure out what the correct formula is. Correct formulas are going to be the ones where the amount of pluses I have and the amount of minuses I have add up to being 0. So usually what I am asking myself is, what is the lowest common multiple between the 2 charges I wrote down, so I can figure out what subscripts I need. Okay. So for the iron 3 oxide example first, iron has a +3 charge and oxygen has a -2 charge. When I finish writing their formulas, I want to have the same number of pluses and minuses, so they both add up to 0 overall. Okay? So if I have a charge of 3 and a charge of 2, the lowest common multiple between the 2 of those is 6. If I can get iron to be 6 pluses and oxygen to be 6 minuses, then it's going to add up to 0, and this formula will be correct. Since the charge on iron is 3, that means I need 2 irons to make this work. And since the charge on oxygen is 2, that means I need 3 oxygens to make this work. Okay. So essentially what I've done here is I've said if I have 2 irons, which are both a +3, and I have 3 oxygens, which are all -2s, then I have a total of 6, and that's the rule. The rule is I have to have the charges add up to 0. Slightly easier example over here where I have calcium at a +2 and sulfur at a -2. If I ask myself, what's the lowest common charge between 2 and 2? The answer is 2. So in the end, I only need 1 of each to make it, so their charges end up being the same, since they're already the same. Over here with magnesium and chlorate, magnesium's a 2 and chlorate's a 1. So if I ask myself about the lowest common multiple between those, the answer is 2. I need to get magnesium to a +2 and chlorate to a -2 to make them the same. That means I need a total of 1 magnesium and 2 chlorates to make this work. Now here's something that's slightly weird. If I just threw a 2 out here next to chlorate, that would look like I needed 32 chlorates. And that doesn't work because I only need 2 chlorates. This is where we end up using parentheses. So putting a parenthesis around that chlorate, I can say I need 2 of that whole grouping. Okay. So taking the name magnesium chlorate and getting that down to a formula, the final answer is MgClO3 parentheses and 2 chlorates. Calcium sulfide is just CaS, and iron 3 oxide is Fe2O3. So tiny things people do. In the end, if you need 3 of one of them to make it work, you need a 3 subscript then. Okay, it's not I need 2 additional to the one I have. It's total when you write them down. Okay, so that's kind of an overview for ionic formula writing from name. Go ahead and do the quiz and have a nice night.